Alright, so on to our fourth and final type of factorizing that we learned to do. And again, I'm just going to return to the idea of factorizing as the reverse process of expansion or multiplying out. So this one here, expand x plus y, x minus y. Okay, so multiply those out. So you multiply x by both things in this bracket. So x by x is x squared. X by minus y is minus xy. Then you multiply y by both things in the other bracket. So y by x is yx, or another way of writing that is just xy. Y by minus y plus by a minus is a minus. Y by y is y squared. Plus xy minus xy is 0. Okay, anything taken away from itself is 0. So plus xy minus xy is 0. So what are you left with? Just x squared minus y squared. Okay. So if you are asked to factorize this to go the other way around, x squared minus y squared, your answer would be x plus y, x minus y. So if you're asked to factorize something which is just something squared minus something squared, so x squared minus y squared, you factorize that by writing it as x plus y, x minus y. Okay, so just seeing another one done again where I'm multiplying it out. So x plus 3 by x minus 3. X by x is x squared. X by minus 3 is minus 3x. 3 by x is plus 3x. Plus 3 by minus 3, so plus by a minus is a minus. 3 by 3 is 9. So I've got plus 3x minus 3x, so they cancel, or they sum to 0. So I'm left with x squared minus 9. It's another way of writing 9. 9 is 3 squared. So if I was asked to factorize x squared minus 3 squared, the answer would be x plus 3, x minus 3. Okay, so it's a little bit different to the ones we've done so far. So the first one, highest common factor. Then we had the grouping, which is just highest common factor a couple of times, and it kind of, we just need to put them into two groups of two. Then we have the quadratics and our guide number. But again, the guide number is just forcing your quadratic to be two groups of two, and then you're using highest common factor. I think it's easier to kind of see that the logic behind the highest common factor ones are more intuitive. This is kind of just a little technique we need to learn off. So if you're asked to factorize something squared minus something squared, it is the first thing plus the second thing, first thing minus the second thing. Okay, so if you're asked to factorize x squared minus 3 squared, it's x plus 3, x minus 3. So difference of two squares. Okay, it is only the difference of two squares. It doesn't work for like x squared plus 3 squared or anything like that. Okay, so the way you recognize these is there's only going to be two terms, and it'll be something squared minus something squared. And we might talk about ways they might kind of hide it a little bit, or some less obvious ones, but these ones are usually obvious enough to see. So this one over here, maybe the first one I'm doing from scratch. Factorize x squared minus 169. Okay, so this isn't something squared minus something squared straight away, but you might recognize 169 as being 13 squared. Okay, if you were to do the square root of 169, it's 13. Okay, so another way of writing this is x squared minus 13 squared. So now I'm being asked to factorize something squared, take away something squared. So I have the difference of two squares. Okay, so how do you factorize the difference of two squares? It's x plus 13 in the first bracket, the second bracket x minus 13. But that's it done. Okay, next one then, 49 minus a squared. Okay, so two terms, one thing minus another. So this might get me thinking, is this difference of two squares? Do you recognize 49 as being anything squared? Yes, 49 is 7 squared. So to factorize this, I need to rewrite it as 7 squared minus a squared. Okay, then that's equal to 7 plus a in the first bracket, 7 minus a in the second bracket. And that's it done. Okay, if you multiplied this out, you'd get back to this. 7 by 7 is 49, a by minus a is minus a squared, the 7 by minus a is minus 7a, the a by 7 is 7a, they cancel. Okay, but if you were to multiply it out, in full and by hand, you would get back to 49 minus a squared. Okay, so they mightn't appear as something squared minus something squared straight away. You might have to do a little bit of work. Okay, so like a really small amount of work there. Rewrite 49 as 7 squared, rewrite 169 as 13 squared. If it was this one over here and you got x squared minus 9, you need to rewrite it as x squared minus 3 squared, and then it's just apply the technique. Okay, so one thing you need to be able to do is recognize the square numbers. Okay, so like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. I would say 169 is probably the highest one, which comes up a lot. Maybe 15 squared is 225. They might expect you to recognize that. 20 squared is 400 is another one they might expect you to recognize. There is an exercise in your book where they just get you to write out the first, I think, 20 square numbers, and I will get you to do that just so you kind of see them all together, and that might help you recognize them. But as I say, kind of 169 I would say is the highest one, which comes up a lot, but up as far as 20 is no harm to know and to recognize those. Okay, so now just on to a couple more. All right, so first one here, factorize 3x all to be squared. So yes, that is something squared. It is 3x all to be squared. So the fact that that's in a brackets and then squared means the whole thing is squared. Okay, we're going to see something else a little bit different over here, but the kind of squared outside the brackets means that entire thing is squared. So yes, that is something squared. Minus 1. We mightn't recognize 1 as being something squared. It's not a square number that screams out to us maybe like 25 or 36 or 64. Okay, but remember, 1 squared is equal to 1. Okay, so you can always rewrite 1 as 1 squared, and that's a tricky one that kind of trips people up. So you can actually write that as 1 squared, because 1 squared is 1. Okay, they're the same thing. All right, so now I've got something squared minus something squared. So to factorize those, 3x plus 1 in the first bracket, 3x minus 1 in the second bracket, and I'm done. Okay, other example over here then, so factorize 25x squared minus 64y squared. Easy to rush into this one and think, yeah, grand, I've got squares here because of something squared minus something squared. But just the way this one is written, 25x squared. So they are saying it is only the x that is squared. Okay, so over here, brackets, 3x close brackets squared means kind of the entire 3x is squared. This one here is 25 multiplied by x squared. So it's kind of only the x that is squared. Same over here at 64, only the y is squared. But you should recognize 25 is 5 squared. So this is 5 squared multiplied by x squared minus 64 is 8 squared multiplied by y squared. Okay, so you can then, another way of writing that is 5x all to be squared, and then this one then 8y all to be squared, a bit more like this one. Okay, you can skip that step though and go straight from here to here. Okay, so 5 squared x squared minus 8 squared y squared, well that is 5x plus 8y in the first bracket, 5x minus 8y in the second one. Okay, so just watch out for those where maybe the number is not squared, just the letter is. You will need to rewrite the number as something squared as well, and then it's just our normal technique. Watch out for 1 Okay, that's kind of nearly a disguised square number. It's one we don't recognize a lot. So if you get -1 or 1 minus, you can just rewrite the 1 as 1 squared. Okay. Other than that, as I say, just the basic technique, x squared minus 13 squared is x plus 13 in the first bracket, x minus 13 in the second. Like, I suppose this would be it, kind of written as a kind of general rule. If you were asked to factorize x squared minus y squared, it is x plus y in the first bracket, x minus y in the second bracket. Okay, so that is factorizing the difference of two squares.